Hello and welcome. In this lecture I want to talk a little bit about the call stack, what exactly it is, and how you can read it to further help debug your program. A stack trace, which is essentially what the call stack is generated whenever your app crashes because of a fatal error. The reason the term stack is used is because it's referring to a data structure that's common in programming. Stack is a data structure that's known as a LIFO, last in, first out. And that's how the data is stored. The last data element that's added is the first one that you retrieve back out. You can kind of think of it if you're eating a stack of pancakes. The first pancake is at the bottom that you add. The last pancake is at the top. When you go to eat them, you eat the last one that was added. And so a stack trace is very useful when your program crashes because it contains information that helps you debug it. So a stack trace shows a list of the function calls that lead to the error. And what will happen is in a program, when you call your main function, that's the entry point. The main function is going to call other functions. Those functions are going to call other functions. And all those functions that get implemented or get called will be put on the stack. And so what you can do is when a program crashes, the call stack will tell you that with the last function that was invoked and the specific line of code that caused the error. So the call stack contains a lot of good information. It will include the file name and the line numbers of the code that causes the exception or the fatal error to occur. The top of the stack contains the last call that caused the error, and there could be nested calls. The bottom of the stack contains the first call that started the chain of calls to call the error. So if you usually in C, that will be at the main routine. You invoke the main invokes another function, which invokes another function, so forth, and then that last line is detailed. It's very, very helpful for app crashes. And so when a C program crashes, it may generate a segmentation fault, and that doesn't tell you a lot of information. It just means something bad happened. That will also generate a core file. You can analyze the core file, which contains the call stack, which will tell you the exact line of code that caused the problem for your crash. So you need to find the call in your application that's causing the crash, and the call stack is probably the best way to do this. And you don't always need to look at that core file. You can also analyze the call stack using GDB with a debugger. You can see the call stack inside of code blocks. And I want to show you what this looks like. A programmer is also able to dump the stack trace at any time. So if you do catch an error or you recognize that a fatal error might happen, you can dump the call stack to see what's going on. If you don't actually know when the error is going to happen, you can still dump the call stack to see the current traces that led up to a particular call. When using GDB, and specifically code blocks, the call stack is going to look something like this. You can access the call stack via the menu when you're running the debugger in GDB. And I'm going to show you how to do this when we go through the GDB debugger and code blocks. But this is what it looks like. And what you'll see here is it has a number, an address, and then the function. This particular call stack here has a lot of different calls. So it must have been doing a lot of different nesting and a lot of different function calls. But at the very bottom of the stack in line 22, it says GT key main. That means it executed the main function. And then on lines 21, it looks like it executed maybe a statement that says main loop run. And then it looks like it called a function called gmain context iterate. And inside that function, there was another call to a IA gmain context dispatch function. So there was an iterate function, then a dispatch function. And then the question marks on line 18 mean that there's no debugging information. It doesn't know what happened there. And that's why when you build your program, you can either build it for release or you build it with debugging information. When you build it with debugging information, it contains extra information when you compile so that when you run, you can look at call stacks. When you release it, build something for release, the executable is a lot smaller and may not contain this information. It may contain more question marks. But this will also tell you if you invoked any libraries, any additional programs, it will call those and will tell you the call stack from there. But what this is showing again is the different nested events for the call. At the very top is what's important because that will signify what caused the crash. So it looks like in this particular call stack, the iter refresh was causing a problem. And you can see that from line 22 to line 0 that there are many different invocations of different code, but the eventual program crashed in line 0. Call stacks, you can also look at call stacks while the program is running to just see information so you can trace it back. So if you put a breakpoint inside of a function, you run the debugger on that, the debugger is going to stop at that breakpoint. You can then bring up the call stack and it will tell you how you got to that line of code. This function was invoked, followed before this function. And again, it usually will start with the main function. You can also switch to different frames. If you're familiar with the stack and the concept, how it's in memory, you can look at different frames. But this is a very useful tool to find mainly crashes in C. And it's very easy to read. If you just look at the top and you don't understand a lot about the call stack, you can look at the top and say, oh, that's a source, that's a line of code that caused the crash. So I'm going to go through the debugger in GDB. I'll show you how you can bring this up. In our particular case, we don't have a program that crashes, so we're just going to look to see what information is in there. But you will want to use this tool when your program crashes. Thank you.